All right, so today, moving on to chapter 8, we have products and powers. So we're going to work on multiplying powers with like bases and raising a power to a power. Hopefully it's review for most of it. Well, we did some of it earlier this year, yes. We're going to make it take it a little deeper this time around. So principles are used to simplify numerical expressions. The same principles also apply to algebraic expressions, okay? Because before we just did like example 1. Now we're going to move it a little more complex. The commutative and associative properties of multiplication are used for multiplying algebraic expressions. So we have the product property and the power product property. The product property is when we are multiplying two things. They have the like terms. They both have an x as a base. What does it say that we're going to do with those exponents? Add them. Okay? So when we're multiplying them, we add the exponents. The power property is when we have a power raised to another power. So there's parentheses here. Okay? What does it show or say that we do the exponents in that case? We multiply them. Okay? So in one case we add, and in one case we multiply. You will have to keep those straight of when to do what. Okay, so if we look at this first one, example 1a, they're being multiplied. So what do we do to the exponents? Add them. So it's going to be x to the 5th plus 2, which would be what? 7.
Oh my gosh, I forgot how much I love this stuff.
So x to the 7th. Okay,
We'll get it.
so this is the product property. How about b?
X equals x to the 3rd power. Or whatever. It's x to the 10th.
Okay, so this is what we call the power property. So we have x to the 5th, and we're raising it to another power.
Subtract when we are adding.
We're not dealing with any subtraction. Yes.
Since it's like back to the first one.
Yep.
Since it's x to the 5th and then x to the 2nd, why isn't it 2x?
Because x to the 5th means x times x times x times x times x, and then you're timesing it by x times x. Whereas 2 to the x means I have 2, or 2x means 2 times x. Does that make sense? Okay. Or x plus x. But yes, good question. All right, so this one is saying x to the 5th to the 2nd power. So what are we going to do with those exponents? We do not add them because we're not multiplying them. We're not finding their product.
When? In C?
In B or C. Because it's x to the 5th, so this is a power raised to another power. That's different than multiplying it. Okay, so we're using the product. Okay, this one is a product. This one is a power raised to another power, which is the power property. So what do I do with the exponents in that case? I multiply them. So this is going to be x to the 5th times 2, which is equivalent to x to the 10th. Good. Okay. So now C.
4 times 3,
We have to do order of operations still. So, right? We're going to do the 3 times 2 first, right? Because this is a power raised to a power. So we're going to have y to the 4th times y to the 3 times 2. 3 times 2 is not 5. So, okay, so then we're going to have y to the 4th, y to the 6th.
So then you're going to multiply them. You're going to add them. Sorry.
Okay, so at this point we add them. So that would be y to the 4th plus 6 is
y to the 10th power.
y to the 10th power. Okay, good. Now this last one is where you have to think about the commutative and associative a little bit.
So then, what if you just take 3 times 5, or would you add them?
Nope, you're right. You would do 3 times 5 because they're like terms. They're both a number. And then you have x squared, so that's times x squared times x.
Would it be 15x to the 3rd?
Yep, it would be 15x to the 3rd.
Because there's already
because we don't ever write the power of 1, but it's still there. Good. Very nice. So yeah, now we want to simplify some more of these. They're getting, there are some like terms, just like we did on the other one. So there's no other number, so we're going to have -8 times x squared, but there's an x here, so times x. Then we have a y. You see that there's a y, and then we have a y here, so times another y. Then we have z cubed, and we have a z squared. So it's a matter of like putting those like pieces together to help you if you need.
So that's.
So it could be -8x to the third. y2.
Because there's one here and one here.
But you're timesing them.
One,
No.
no, you're adding them because they're being multiplied. This is the product of y times y. It's not y to the 1 to the 1 power. You mean in this case? No, this is y squared because we do 1 plus 1.
Okay, and then it'd be z6.
Not z to the 6th. Because so like here you added them. You had x squared. There was 1 here, so you added them. You add them. You add them.
The only time you multiply is when you have parentheses or ignore the exponent. You could probably explain that.
When you have, like this one, when you have an exponent, you do multiply them. But here, 1 times 1 is just 1, y to the 1 power. But if you have y times y, that's actually y squared because it's 1 plus 1. So that's the thing. If there is a multiplication, like if they're being multiplied, you add the exponents. If they are being raised to another power is when you multiply the exponents. Like this one. See how it's being raised to another power? That is what we're talking about. That's when we multiply these together. Okay, so in B, we need to break this down. There's a negative sign here. What does the negative sign represent? Not a negative A. Not a negative A and B. Not AB squared. -1. The negative is for a -1. Okay, because we don't have another. So this is -1. Okay.
So would it be, so
Then why didn't we do that on the other one? We didn't do
you
that.
would distribute 3 to -1 and b squared.
Okay, so just a second. Why didn't we do what to the other one? Because it had a -8.
What about the positive one?
We don't need to do anything with a positive one.
So you're saying it's we only do it if it's a negative.
Because the negative, we don't write the number 1. Like
Oh, yeah.
1
It's
to
implied.
any exponent is 1. -1 is not -1 to any exponent. -1 squared is equal to a +1. -1 cubed is equal to a -1. Like, so you have to take, I mean, like, you can't just ignore it because of the outcome. We're not ignoring the 1. We just know that a +1 to any exponent up here, any exponent at all, is always equal to 1. So we're not really ignoring it, okay, if we think about it. But that's a good question about, like, why do we have to take the -1? Okay, so the negative represents a -1. What do we need to do with it?
Multiply it by the AB.
No, multiply
Okay. Multiply it by A, multiply it by B. Now what?
You have
Well-
-A and -B.
Mm,
No, just negative.
but what you're doing doesn't help with, like, that just takes it back to -AB. You're not actually doing any simplification of the math.
Oh, you're asking us to continue it.
Like, yeah, I mean,
Wouldn't it be
Mm-hmm.
you would distribute the 3, so you would times the 3 by everything in there, so it'd be -3 and b.
No, I'm not multiplying it by 3. If I understand you say distribute the 3, but it's an exponent. It's not a number to be multiplied by each one. It's a power for it to each one to be raised to. So like you say, this is going to be.
-a3 and then b6.
Wait, where'd B6 come from?
Because there's a b2 in there.
But we didn't write the B2.
We need to write the b2.
Oops.
I was like, nobody caught it. So this is supposed to be squared. But yes, then the 3, the exponent of the 3 applies to each part. So this is -1 to the power of 3, a to the power of 3, b squared to the power of 3.
Wouldn't it just cancel?
Turn around.
You don't need to put the exponent on the -1 because
We're showing, like we're putting it there because we need to show, like Bailey asked earlier, why didn't we do it to the regular 1? So we talked about that. So yes, we do need to put the 3 on the -1. But what does -1 raised to the 3rd power equal?
-1.
-1.
If it was a positive number, then it wouldn't matter because then
Not
you could just take off the negative entirely.
Not positive. Negative.
Okay.
Sorry.
If it's a positive 1, correct, it doesn't matter. But if it's a positive other number, it does matter.
I'm saying if it was, for example, -1 to the 2nd power, it wouldn't matter anymore because -1 times -1 is a positive 1. And you can just not worry about it.
Right, but you still need to show your work. So, because we have to show our work, yes, we need to still write it. If it's a -1, if there's a negative, or if there's any coefficient out there other than a positive 1, then you must show it. Okay, so what is -1 to the power of 3 equal? -1. Okay, so we're going to have -1. What's a cubed equal? A cubed. What's b squared to the power of 3?
b6.
Does anybody confirm that?
Yeah.
That is, you're just thinking, I got that, you're good. So it is b to the 6th. We have to multiply those together.
Dang, that's confusing.
You were just telling me how much you love it.
I love that first part.
Yeah, that's why I said, like, the first part is what we kind of started with earlier in the year. And so now we're taking it to the next level for you to understand it. Okay? Too bad.
Ready or not.
The power of a product is equal to the product of the power. So if we look at this part right here, it's kind of what we just did. If we have A, B, and C in parentheses, all raised to the power of n, then that exponent, n, applies to each part of that. That's the exact same thing we just did up here. Okay, but now we're going to, we're going to keep looking at that. And the other thing, only like terms can be added when you are simplifying. Okay. Okay, so let's look at example.
We need to distribute the exponent.
Okay, so we need to distribute
Both of them.
this exponent of a 3 here. So we're going to have Bailey, Malin, what are we going to have first?
Sorry. We will have -2m.
Nope, we want to distribute the 3 to each term.
Okay.
So -2
3.
to the 3rd. Okay, good. Josie, what are we going to have next?
Then we're gonna distribute the 3 to the n.
We're not at the n yet.
Oh, the m. Sorry.
Okay, so what's going to be?
And that's gonna be a 12. To the
So we're going to show the work, so it's not 12 yet. We're going to take,
m. Parentheses.
no, it's m to the 4th. Okay, we're going to put the parentheses now, just like we did on the previous one, to the power of 3. Okay. Abigail, how about the next one? N? Okay, so that's our first one. right? We've shared this exponent to each of those, just like it showed us right here. All right, so Bailey DeFries, can you do the next one for us?
So it's gonna be. Well, sorry. 1/6 squared.
Okay. All right, Connor, yeah, you haven't done one yet.
So the next thing you would do is do m squared.
M squared. Okay, Cameron.
Then you would do n squared and then n parentheses squared.
Okay, good. So we just shared that exponent. Okay, so Chase, what's -2 cubed?
-2 to the 3rd power.
Yeah, what is that cubed?
Oh,
Or what is that?
sorry.
Like, because this one you can actually solve.
It's negative 8. Sorry.
-8. Okay, good. So we've got -8.
We're just simplifying.
-2 times -2 is a +4. And then +2 times, or +4 times the -2.
We're actually now taking it. Okay.
Yeah, simplify, we're actually simplifying it down. Like we showed the work how we're sharing the exponent.
We can't simplify a variable.
And so, but we can simplify the numbers. You got it. Okay.
I thought it would be like -2 4 because to the 4th power because we would like add.
Nope, we're simplifying it down. Okay, so Cheyenne, how about m to the 4th to the 3rd power? What do we do with those exponents? We do multiply them together, so that's going to give us m to the 12th. Excellent. Okay, and Connor, how about the next one? N to the 3rd. Okay, so I'm going to put my parentheses around this because we haven't actually done any multiplication yet. We're just in the process here. How about the next one? 1/6 squared. Can anybody do that one for me? I don't want to put you on the spot.
It's 1/36.
Okay, so this is 1/36. Okay, m squared. Okay, Cameron, how about the next one? N squared squared. N to the 4th. What'd you do with the exponents? Good. All right. So now we've got that exponent taken care of. How do we simplify further? We haven't done one like this yet. Yeah, Connor.
Take the m and the m and add them together. So add the same variables together.
Okay, so we can, this case, we've got an m here and an m here. But here's the thing. Are they being multiplied together? Or is it a power raised to a, hold on. Are the m's being multiplied together or are they being raised to another power? Okay, so this is when they were raised to another power, right? Like here. We're combining like terms, but also when we just have two numbers beside each other with separated by parentheses, it's multiplication. So if we're multiplying m to the 12th times m squared, what do we do with the exponents? Add them. Okay. M to the 14th. Good. What other terms do we have that are like?
N3 and N4.
Okay, n to the 3rd and n to the 4th. So that's going to give me n to the 7th.
And you simplify -8 to, you could add them to get.
We don't add them because they're being multiplied.
Oh, no, they are being.
Right? It's multiplication. So -8, yes, times 1/36. -2/9. Okay. Can you combine anything else?
No.
So you have simplified the problem.
Wow, that
We did
was
it.
a lot of work.
It was a lot of work.
It feels good.
Just like our one problem for the homework on 27 that we graphed all the lines and found the little triangle, right? It was a lot of work for just that one little thing. Okay, how is B different than A?
It's not in parentheses.
Why is it not in parentheses?
It doesn't have fractions.
Okay, it doesn't have fractions. It's not in parentheses because we're not multiplying. We are adding and subtracting this time.
So
Okay.
This you can, okay.
And again, only like terms can be added when you are simplifying. Here we were multiplying, so we could put m to the 4th with m or m to the 12th and m squared. We could combine them because we were multiplying them. When we are adding and subtracting, they have to be identical terms in order for us to add them together. So x squared is not equal to x. Okay, we can't add those together.
What do you do?
So just a second. If I look at this one has x squared, x, y squared. Do these others have x squared, x, y squared?
No.
No. So you must be done.
Oh, yeah, we're
Why not, Bailey? You don't think it would be done yet?
You wouldn't
you
just
need to
stick
add
a probable
your-
on there just to argue.
Well, you
I
can
wouldn't.
combine
Oh.
like your x's, your x to the seconds, those two, and then but you need to make sure.
You can do that in multiplication. You cannot do that in addition. Like, you mean this x squared with this x squared?
Yeah.
No, not in addition. They have to be alike. They have to be exactly identical.
Aren't they still like getting multiplied though? Like the x squared and the xy.
Isn't, are you saying, is this still getting multiplied by this? No, they're being added.
Like in their own
You
like,
can.
sections.
Keep going. Yes, I do.
Like aren't they still? We still need to like multiply them together and then add.
So like in this one, what are you saying? Like in the first one here, x squared, x, y squared. What are you saying they're still multiplied together there?
Like your x squared and your x to 1 technically can come together, which would make x to the third.
Yes, there we go.
And you can make x to
So because we have x squared, this is x squared times x to the 1. So this is actually x cubed y squared.
we can make x
Very nice.
and we can make x cubed on the next one too.
We can make an x cubed on the next one, right? We have an x and an x squared. So this is 3x cubed y. And what's our last one?
5x.
Yeah, 5x just stays.
The 5x cubed just stays?
Yeah,
there's a y.
it all stays.
It all stays. There's nothing to combine. Okay.
And that's it. That's all.
So now do we have any like terms?
Yes.
Yes? Which ones?
The first x, all 3 x's.
No. This is, so the term is x cubed y, hold on. The term here is x cubed y squared. They're together. The term here is x cubed y. Those are not
It's
the same.
first and the second, the third one.
Okay, the first and the third. Okay, because when we are talking about terms, we are talking about this chunk has to be identical in addition and subtraction.
But don't we have to put on? Wouldn't the subtraction sign like be your negative or no?
We take the subtraction sign with it. So this is saying 1 x cubed y squared minus 5 x cubed y squared, which is how much?
Negative. Doesn't that just simplify to -5?
Not to negative 5 because this is a 1. We never write. What's 1 minus 5?
What? Negative 4.
So it's the same thing. This is just a one of these. It's like a semi-truck and a trailer. Okay, like this is the trailer that it's hauling, right? And we can't say like, hey, there's 3 Walmart trucks because this one doesn't say Walmart. It says Target on it or something else because it's not the same. Okay?
Okay.
So, but this is saying there's 1
It's
and there's negative 5 of these. So 1 plus negative 5 is
6.
No.
1
negative 4.
plus negative 5 is negative 4 x cubed y squared. This one, like you said, doesn't match the others. So it just stays.
Wait, no. Never mind.
So this is your simplified answer. Yeah.
Oh, there isn't a back.
There's not a back. Nope. That is it.
So